just a reminder before we start our day 2 of our quadratic applications here. The thing that you see on the front not only is on the front page of Classroom, but you should have it in your hands right now at this point if you do not. So one of those 2 ways, we'll be checking in all of these momentarily. So we flip over. So first things first, let me get those out of the way. The question is always, first, what am I looking for? Am I looking for, as we drew over on the sideboard, am I looking for a maximum or am I looking for a 0? An egg is dropped from a height of 105 feet. How long does it take for the egg to, drop to the ground? Okay, I want the 0 in this case. So again, depending on how you want to do it, I left space for algebra. We can play the calc as well because I want to make sure that we're on top of things with this. So if I'm going the calculator route, okay, we're going to type our equation. You're like, Hardy, wait, what equation? Oh, yeah. Here's my starting height. So my equation, how long does it take to hit the ground? Oh, that would be my h value. So 0 equals negative 16t squared plus 105. So let's get this into y equals first, and then we'll get the rest of the page over here so we can see. So negative, not minus, 16x squared plus 105. So let's see if just the regular old calculator is going to get what we want. Okay, there's what I want. You're like, well, wait a minute. Why can't it be this one? Okay, remember, this is time. How much time has elapsed? This is negative x. Negative time, that makes no sense. This isn't like a sci-fi movie. So we want this one. So if we're going the calculator route, let me pull this up where we can see. Oh, that's not fun. So we saw the max. Oops, not max. Hardy, we're doing the 0. Get down here, the right one. Zoom standard worked. Second, trace. We want the 0, number 2. Hardy, can't see my cursor. Okay. We're going to be using the left and right arrows to get it, but you're like, I can't see it. So here's our deal. I want it over here. Where is it right now? Right now it's at 0. It's over here. I want it over here. Makes sense that I'm going to start hitting the right arrow, and until I get, it looks like it's between 2 and 3, it should show up once we, oh, there it is. There it is. So once we've got it in sight, and that's kind of close to the x-axis. That's cool. We hit the arrow left 3 times. 1, 2, 3. It disappeared. It's okay. And hit enter. And our first boundary is going to be set. That little arrow and that faint little line. Once that's set, the question changes to right bound. We're going to hit the right arrow. 1, 2, 3. I'm back where I'm started. And 3 more. 1, 2, 3. Disappeared. Don't care. And hit enter. Now I have a left and a right boundary here. And we hit enter one last time for the guess. And there's how long this is going to take. It's going to take like 2.56 seconds. Now, if you are not the calculator person, you're like, nope, don't want it, don't need it, don't like it. Okay, if you're going that way, I'm just going to rewrite my equation here for a sec. What's that?
I think you should retype this into the calculator after you're done, so that I know what you typed in, because I didn't know what you typed in.
Okay. So, if I'm going to go this way with the algebra option, I do run into one quick dilemma here. You're like, well, wait a minute. Label A, B, and C. That's A. That's C. Because if I'm looking up here and you're talking about A, B, and C, you said the number in front of x squared is A, the number in front of x is B, and the last number is C. But there is no middle term. So, I'm just going to rewrite this for a second. If there is not a T, or you can make those X if you want to, I don't care. I'm going to put it in this way, so now I have A and B and C. And I need those because I'm going to be plugging this in to this here quadratic formula. So once I've got all the numbers labeled, you're like, Hardy, the opposite of B would be 0 still. Okay, 0, plus or minus, I'm okay with this. Square root of B squared, 0 squared, minus 4. Uh-huh. The question was, if you couldn't hear it at home, can we use X instead of T because it kind of goes with what already has here? Absolutely. Times C all over 2 times A. Okay, advice. First thing we want to do. You can't put this whole blessed thing in the calculator at once. It will not work. So, we're going to get out of here. That is just part of the quadratic formula itself. It's just the form. Yeah, it's not any numbers that I'm getting from the equation that I'm doing. Good question. So, I'm going to type this in exactly like I got it here. You're going to get funky answers. That's okay. So here, for instance, let's say we'll call this 0 plus or minus 81.97. That's pretty close to like 82. So we're gonna call this 82. And 2 times negative 16. Oh, that's not good. 2 times negative 16, there we go, is negative 32. So here's how I get to the answer now. We're almost there. You notice this plus minus here. So I can have 82 divided by negative 32. I can have negative 82. Uh-oh. Whoop. Let's come on over. So I basically just took the plus minus and split them. I took my positive 82 divided by this, and I took my negative 82 divided by this. And now I'm going to see which answer makes sense. This answer is negative. Negative time? I don't think so. Let's try this one out. Hey, check this out. 2.56. Same thing. So algebra works. The calculator works. It's just how do you want to tackle it? Okay, so that's one thing that can get thrown our way. If I look at the next one, and I'm going to shrink this a little bit so it actually starts fitting in the screen instead of us flipping back and forth here. Okay, a tomato is tossed in the air. Oh dear. It leaves Brian's hand 4 feet above the ground and has an initial velocity of 35 feet per second. The tomato misses Aaron and lands on the ground. For how long was the tomato in the air? Now, don't get tricked. Don't get tricked. The tomato lands on the ground. I still want the 0. I still want to know how long is it taking for that tomato to leave my hand and hit the ground. So, I'm like, okay, got this. lands on the ground. My h value is 0. We know the negative 16t squared doesn't change. Here's my v sub o, my initial velocity. And again, if you want to be putting x's here instead of t's, that is a-okay. And my initial height was 4 feet above the ground. So we're in the same situation that we were up above in the last one. You can either, this one I'm going to move a little quicker this time, but we're still going to do all the things. Equation in here. We'll take a peek at our graph. We'll see what's happening here.
Why is my graphic like that?
You need to hit zoom and hit number 6 for standard. So you get a normal looking graph.
Okay, thanks.
Absolutely. So we want this one. We're always going to want the one over further to the right. So second trace, we want the 0. We're looking for the x-intercept. And this time I can actually see my cursor, at least for a moment. But I need the cursor over here. So we're going to start hitting right arrow. Already my cursor disappeared. It's okay. It will come back. Oh, there we go. There we go. Okay. So cursor by the x-intercept. Left bound again. If I'm looking at these, arrow left 3 times. 1, 2, 3. Enter. There's my first boundary. Next, arrow right. 1, 2, 3. Back where I started. 4, 5, 6. Enter. Both arrows are there. My boundary has been set. Hit enter one last time for the guess. 2.296. Now, before some of you start looking at y and going, wait a minute. What in the heck is that? That's the calculator's really funky way of saying 0 sometimes. 1e to the negative 12th means negative 1 to the negative 12th power. So put 11 decimal places in front of your 1. That's really close to 0. Like that would be, how close to 0 is that? Let's see here.
We did negative 16, right?
Yes. So that's the value they have for y. That's close enough to 0. We're just going to call that 0. So 2.296, probably going to be 2.3. So we're going to say 2.30. 2.30 seconds looks good. If you are the algebra person, A, B, C, and back to the quadratic formula. We go. So let me get that above my head. There we go. So let's see here. The opposite of b, we actually get to do that this time. Plus or minus the square root of b squared minus 4ac all over 2a. Get that out of here because I need the calculator to help me out here now for a bit. Okay. Do not do this part yet. Again, we're just doing this at the start. So 35 squared minus 4 times negative 16 times 4. Negative 35 plus or minus 38.5, we'll call it. We'll go a little decimally here. Over negative 32. Now, here's the part that you've got to be careful. Because I know some of you are going to want to put all this in the calculator at once, and it's going to get you into problems. So, If you are bound and determined, you are putting this in one step, and that is it. You have to have parentheses around the stuff you have at the top, or this is going to turn out really bad. Well, you're not going to get the right answer. I guess there's worse things in life than getting the wrong answer in math class. Negative answer. No Gouda. Oopsie. Same answer I got with the calculator. Uh-huh.
Okay, so two things. One, I thought it was supposed to be 0 plus or minus. Why is it -35?
Because when we did it for number 11, I didn't have a t term in my initial question. So I put in a 0 for it to hold the place. That was my b value on this one. This one, we actually had a value in the middle. So whatever this is, and again, if you want to make these x's, you can. But the number in front of the squared term is always a. The number in front of just the variable itself term is b. And the term with no variable is always going to be c. It's always going to be in that order.
Do we always change the sign when we put it?
When we put it here,
Yeah.
yes. Because when we do the quadratic formula, this always says the opposite of b. So yeah, I always got to switch the sign on that one.
And also, I set it up pretty well, but I put that like top row in my calculator, and I got 1481.
Did you have the square root on it? I bet you that's it.
I might have.
Yeah, I bet you that, because I think 38.5 squared is about 1400. So I bet you that was your problem if you got something else. You double check that. I got one last thing we're going to check here. Last one. I appreciate your patience, and I'm hoping you're starting to see you can do this. Suppose a ball is released from a point 5 feet above ground level with an initial vertical velocity of 44 feet per second. I will spit this out. When does the when does the maximum height occur? X value of the max. What is the maximum height? The y value of the max. Oh, and then we get to have more fun. When does the ball get to hit the ground? 0. We get all the things on this one. Oh, this is like the super duper question. Okay. So, once the ball hit the ground, my h is going to be 0. Gravity has not changed. I'll use x this time instead of t. Initial velocity, 44 feet per second. That's always in the middle. And this is where we started, 5 feet above the ground. Yep, unless it says meters, and if it does, I'll put the change in there for you so you're not wondering. But yeah, most of ours are going to be feet. So I get this, and I go, okay. Now I need to do the max thing. So we're changing up for the first time. If you are going calculator, we will see both. I will not mess with either group getting what they need here. So first things first, I want to keep my equation on, but I want this. Okay. Get the equation into y equals. Let's do this. Negative 16x squared plus 44x plus 5. Bam. Okay, I have an issue. My maximum's up here somewhere. I can't see it. So as we have here on our sheet, it says if you cannot see the maximum, use zoom number 0. There's zoom. Zoom, gotta scroll down a little, number 0. Zoom fit so we can see, there's the top, we can see it now. So my job now is to go ahead and do second trace. Number 4, I want to find the maximum. So I see my little cursor friend there. I want to move that a little further to the right because I want it to be as super close to the maximum as I think I can get. Well, that's pretty close. I think I'm in the ballpark here. So once I do, it's the same deal as when we did the 0. Left arrow. 1, 2, 3. Enter. There's my first bound. Right arrow. 1, 2, 3. I'm back where I started. 1, 2, 3 more. Enter. Both my boundaries have been set. One last enter. I actually just got 2 answers. The second what? I'll play this again in a minute. I will. I'll even rewind myself here if I need to. Once I get these followed and I get these 2 values, I'm going to try to get this where we're not too glary. Oh, glare. X value of the max, 1.38 seconds, it's time. Y value of the maximum, 35.25. We'll just call it that. That's fine. Feet. That's my height. You're like, okay, so what about the last question? Oh, Hardy. I got to go back to the other thing, don't I? Yeah. If you're going calculator, yeah. We're going to go back to Zoom standard, Zoom number 6. Because at Zoom number 6, I can see that, which is what I want. And then we know what we got to do. Second, trace, 0 this time, not maximum. We want the 0. There's my little cursor friend. Needs to be over here, though. Give the cursor friend help. To the right we go. We will be there in no time. Okay. Left bound. You know the drill. Left arrow. 1, 2, 3. Enter. Got to make sure you hit enter. Left boundary's in. Arrow right. 1, 2, 3. Back where I started. 4, 5, 6. Enter. Both my boundaries are there now if I've hit enter after each one. And the only question left is guess, and I don't need to guess. I just need to hit enter one time. And there is the magic 0, 2.86 seconds. Bam. So calculatordom, that's what it looks like. Again, my non-calculator crew, I won't call you the anti-calculator crew because it doesn't mean won't ever use a calculator. Goes, I don't like this calculator thing. Okay. So if we're doing the maximum, we're okay with this. This is going to be a short little thing we got to do. First job, I need to know what my A, B, and C values are. So A is negative 16. B is 44. C is 5. Number in front of x squared, number in front of x, number on the end. Here's the good news on this one. This one's going to be short. To find the x value of your vertex to find out the time, you do the opposite of b. The opposite of 44 is negative 44 over 2 times a. 2 times negative 16 is negative 32, just like it has been all these other times. And watch the magic occur. Negative 44 divided by negative 32 is 1.375, which rounds to 1.38 seconds, just like it was up there. To get the height, plug the x value in that you got in step 2 into the equation. Okay. Every time I get to an x, I'm going to plug that in. Next x. And again, so I don't cover it up, I won't put my calculator over there until I have got the answer to show you so you can be completely amazed. Oh, 35.249 rounds up to 35.25 feet, just like it was there. Last one. Ball hitting the ground, algebra people, and we got just enough room left to do this. I've already got my A, B, and C right here. So again, there is my quadratic formula. The opposite of B plus or minus the square root of B squared minus 4A C all over 2A. All right, let's do this. Square root of 44 squared minus 4 times negative 16 times 5. Whack. 47.5, we'll call it. It's lucky we don't have a lot left to do because we're running out of room. Let's see here. Negative 44 plus 47.5 divided by negative 32. Negative number. Not that one. Negative 44 minus 47 divided by negative 32. Oh, what did I do? Oh, that's what I did. 0.5 Hardy. Bang. 2.86. 2.86. Oh. So at this point, you have got to choose your weapon. The calculator or the algebra in which to tackle these. I'm still not going to do the rectangle problem today. I'm going to do it tomorrow. So, I got So, if you had shut down on numbers 2 and 3 yesterday on page 11, do them now. If you didn't, if you fought your way through that and said, no, this will not shut me down, good. That's a good thing. Because on the next page is worksheet 2. That's the practice for today. Now here's the good news. Tomorrow we're going into workday mode. So you will have some time. It doesn't mean don't do any of this right now and sit and fall away onto your phone for 10 minutes and then not know what you're doing tomorrow. That's not the idea. Work these through. If we need to play with it some tomorrow, we can. If we need to practice something, we can. If I need to come and help you with something, I can. But I need you to be trying these. So give them a run. Let me know if you're having issues, and that'll